Hi everyone, this is Asha. I'm working as an assistant professor in the Department of Artificial Intelligence and Data Science. In this series, I'll be teaching the subject Design and Analysis of Algorithms. Each video will cover one topic in a clear and simple way. Let's get started.
Hello students. So today we are going to see about knapsack problem using branch and bound method. Already we have seen the same problem with different methods like brute force and dynamic programming. So today the method is different, that is branch and bound. First of all, what is the meaning of branch and what is bound? See, in general, what is the meaning of branching in trees? How we'll separate, like in the trees means we'll have several branches, right? Likewise, if we have a main problem, a big problem, it can be splitted or it can be branched into sub-problems. So branching is nothing but process of generating sub-problems. Okay, then what is the meaning of bound? Bounding refers to the ignoring the solutions of, that is, which is not good. That means we will be selecting only optimal solution, right? So in case if there is some solution which is not perfect or which is not apt, we can omit that. So branching means first the main problem is divided into sub-problems, and bounding nothing but you are ignoring the solutions which is not apt for this problem. That means partial. Okay? In this session, for the given sum, we are going to implement the construction of state space tree step by step. Okay, so we can see the problem, always knapsack problem, in the sense how there will be a sack or a bag like structure which will have a capacity, and there will be several items to be placed inside that knapsack. So each item will be having a particular weight and a value. Okay, so this is what they have given in the problem. So now let us solve the problem. Now we have to find the value of the last column, that is a column which is empty, value by weight. Okay, so that means we have to divide the third column by second column. After that, the upper bound formula, we have to apply the upper bound formula for knapsack. So the formula is nothing but upper bound equal to value, that is nothing but the given value, plus capital W. What is capital W? That is nothing but the total weight. It is given as 10. And small w is what? The individual weight of each item. So V plus W minus W into, you have to add the value, that is item number should be added, Vi plus 1 divided by Wi plus 1. That means the next. For example, if the item is 0, then we have to divide V1 by W1. If the item is 1, then we have to divide V2 by W2. Likewise, we have to do. Okay, so we have to find that values now using the upper bound formula. As I mentioned earlier, we are going to construct the state space tree. Okay, so for that we have to consider the root node, that is the base node, where the value of I will be 0. Because we are in search, right? So level by level the value of I will get incremented. So this is how we are going to construct a tree. Tree means what? First we will have a parent node. From that we will be having several branches like child node, isn't it? So as I mentioned, at root node the value of I is what? 0. Okay, for the next search we have to move to the next stage. In that case the I will be equal to 1. So for each stage the value of I will be incremented. Now we will start the state space tree. First level is root. That means we will represent it as node. Okay, node 0. So n will be equal to 0 and w is also 0 and the value is also 0. Now in this case we have to apply the formula and we have to find the upper bound value. Got it? Now just observe the formula. We are going to find the value of node 0. Okay? So at node 0, the item is also 0, W is also 0, V is also 0. Because when you look the table what they have given, in that the item starts only by 1. So we don't have any such item. So for that item number 0, the corresponding W and V value will be 0. Now we have to apply the formula. Upper bound equal to value, that is nothing but V plus total weight minus the individual weight. Since V is 0, we are substituting 0 plus total weight is what? 10 minus individual weight is what? 0. Okay, into now comes Vi plus 1 divided by Wi plus 1. Actually the I value is what? 0. But you are moving to the next index. I plus 1 means what? 0 plus 1. That is nothing but V1. Wi plus 1. W0 plus 1. Okay, so V1 by W1. So if you look at the table, what is the value in V1? That is 40. What is the value in W1? That is 4. So 40 divided by 4 is 10. Okay. So when you substitute everything, that is when you calculate, what will be the upper bound value for node 0? Now it is 100. Okay. So now you can calculate node 1 also like the same. So if you see the table, now for node 1, that is for item number 1, what is the corresponding weight? It is 4 and the value is 40. Now you have to substitute the same, that is 40 plus total weight 10 minus individual weight is what? 4 into V2 by W2. What is V2? V2 is 42 and W2 is what? 7. Just look at the table. For item number 2, the weight is 7 and value is 42. So value divided by weight. 42 divided by 7. The value is what? 6. So when you substitute all these things, the upper bound value for node 1 is 76. So now using this value, we are going to construct the state space tree. So shall we update the value? Now this portion is very important. Please listen carefully. If you observe the question, weight for first is what? That is for first item the weight is 4. Now we have to derive W1, that is with weight and without weight. For each node we have to derive 2 branches. Left side will be with and right side will be without. That's what I mentioned, W and W0, that is without. Okay. So W1 is nothing but with weight and W01 is nothing but without weight. So now when you look at the table, what is the value of item number 1? W is equal to 4 and the value equal to 40. So actually we have calculated, right? So now I am just updating the upper bound value for node 0 and node 1. That is nothing but 176. Next we have to move to the next node. Okay. See, whenever you are deriving the new node, you have to retrace, that is you have to calculate the total weight of that path. Now listen carefully. For node 2, that is for item number 2, the weight is what? 7. But for node 1, the weight is 4. That means you have to add it. I have mentioned clearly using the diagram. So weight of node 2 is 7 and weight of node 1 is 4. So 7 plus 4 is 11. But what is the actual capacity of the knapsack? What is the value of capital W? That is nothing but 10. So that means it is not feasible. So we cannot derive or we cannot construct further. So we can stop this on the left hand side. That is with weight. Now we have to go for without weight of node 2. Got it? Now using the upper bound formula, we are calculating the value of node 3 as well as node 4. Okay. So I have shown you like which values we have to take. Just take the values, substitute it and you will get the upper bound value. So now we'll see how to update this value in the state space tree. Okay. When you observe the node construction, that is for without weight, you should not add the previous weight. Only for with weight you have to add the previous weight. So if you see node 3, how it look like? W equal to 4, that is without weight, right? So only the present weight you are taking and the value is 40. So for that, what is the upper bound value? That is 70. So I have updated in the graph. Now in the same manner, we have to calculate for next node, that is node number 4. Okay, so that is weight, with weight and without weight. Left side is with and right hand side is without. So this is what item number 3. Okay, so when you look at the table, what is the weight in item number 3? That is 5. And what is the previous weight? It is of 4. So 5 plus 4 is what? 9. Okay, and now take the value. The value of item number 3 is what? 25. And the value of item number 1 is 40. See, since we are not considering W2, because W2 is what? It got rejected, right? It's not feasible. So we have to add only with the previous. So W3 is added with W1. That means third item is added with item number 1. So item number 1 weight is 4. Item number 3 weight is 5. So 5 plus 4 is 9. So here in node number 4, I have mentioned W equal to 9 and V equal to 65. That means value of item number 1 is 40 and value of item number 3 is 25. So 40 plus 25 is 65. So now using this value, we have to find the upper bound for this. So by substituting the value for node 4, the upper bound value is what? 69. Okay. So when you substitute for the formula, V is what? 65 and capital W is 10 minus the individual weights. So individual weights is 5 plus 4, 9 and V4 by W4. So V4 by W4 is what? 12 by 3, that is nothing but 4. Okay. So the answer is what? Upper bound answer is 69. Now this value should also get updated in that tree. Now when you start constructing the next node, that is node number 5, just see W. So W equal to, we have to add the previous one, right? So what is the item number 4 weight? It is 3. In node 4, what is the value of W? That is 9. So 3 plus 9 is what? 12. So it is not less than the total weight. So it is not feasible. So we can omit that node. Understood? So now we are going for without weight. That is right hand side. So on the right hand side, what did I say? If it is without weight means you need not calculate, you need not add any weight. So you will say take the same weight. So W equal to 9. And the value is what? 65. So now using this value, we are calculating the upper bound value for this node number 6. So I have found the value of node number 7 and 6 also, and I will update in the tree now. So when you are going to calculate the value for node number 6, you have to concentrate on item number 4. It is without weight 4, right? And when you are calculating for node 7, you have to concentrate on item number 3. So likewise, you have to take the value and you have to substitute. So the value is nothing but 65 and 64. Now we have got everything. And finally, we have to find without weight for W1. Okay. So what did I say? If it is without weight means what? The value of W and V will be same, right? So in node 0, W is also 0, V is also 0. So in without weight also, V and W will be same. But using the formula, when you calculate, the value of Vi plus 1 and Wi plus 1 will change the upper bound value. So now the obtained upper bound value is what? 60. Okay. So now I am going to update this value in the state space tree. So after constructing the full tree, now you can just go through and see which is the value feasible, which is the feasible value. Okay, so when you look at that diagram, we can find that 65 is the highest value. So you can conclude that 65 is highest. You may wonder how 65 is the highest. Okay, let me explain. Now look at the constructed state space tree. See, when you observe that, we can conclude that which are the items or got selected. See, W1 got selected, but W2 has got omitted because it is not feasible. The value of W2 is what? 11. It is greater than the capacity of that bag. Capacity of knapsack is what? 10. So we cannot take W2. And next, if you see W3, it is what? 9. But W4 is what? 12 again. So I cannot consider that. So from this, what is the conclusion? W1 and W3 is got selected. Now just look at the value for this. What is the weight? What is the individual weight given in the table? W1 is what? 5 and W3 is what? 4. Okay. So what is the total? 5 plus 4 is 9. That is for item number 1 and item number 3. You have to look at the value. So it is 9. But 9 is less than the total capacity, right? So 9 is less than 10. So it is satisfying the condition. At the same time, we can cross-check the value also. W1, W3. That means what is the value of V1 and V3? In the table, V1 is what? 40 and V3 is what? 25. So when you add these two items in the knapsack, the capacity of the bag should not exceed. So weight is not exceeded. And the value is what? 40 plus 25 is 65. So this is what we have derived, right?
Thanks for watching.